I gave them like a book, I think. I was like, oh, this is representative of our culture and blah, blah, blah.
I wouldn't convince them.
All right, so we were talking about limits to infinity the other day. So remember, there's like three scenarios. Either the order of the bottom is bigger, in which case the limit's 0, or the limits are equal. Not the limits, the order. The order of the top and bottom are equal, in which case it's just the fraction of leading coefficients. Or the order of the top is bigger, in which case it's either positive or negative infinity, and according to the Delta math, it doesn't exist. Any questions about that? So today, I just want to talk about first how to determine whether it's positive or negative infinity in that third scenario. Okay, because actually on tonight's homework, they want you to say it's in positive infinity or negative infinity. They don't want you to say it does not exist. So let's just talk about that. So this is just more limits to infinity. So let's take a problem where we know that to be true. How can you tell if the limit is positive or negative infinity when you look at a rational function? I mean, how can you tell that it's one of those scenarios? Yeah, if the top is bigger. So I'm just going to make up a random problem where the top has a higher power than the bottom, okay? So like, for example, the limit as x goes to positive infinity of 5x cubed plus 2x squared minus 3x plus 1 over x minus 3x squared. So the top has a bigger power than the bottom. So I know that this answer is either positive infinity or negative infinity. So here's how you can tell which one it is, okay? And it goes back to what we were talking about on Tuesday in terms of the dominant term of a polynomial. Like if you look at the top is really dominated by this term if you plug in really large values, like a billion. 3 times a billion squared, or sorry, 5 times a billion squared is much, much, much larger, or cubed. 5 times a billion cubed, it's much, much larger than all this other stuff if you plug in a billion to it, okay? This overpowers those terms completely, okay? So if you look at just the dominant terms, which is just the term with the highest power of x, on the top it's 5x cubed, on the bottom it's negative 3x squared. All you're going to do is you're just going to take any number that's positive, since we're going to positive infinity, and substitute it in here and here and see if you get a positive or a negative. If that ends up giving you a positive number, then the answer is going to be positive infinity. And if that ends up giving you a negative number, then the answer is negative infinity. Because the term is so dominated by those leading terms. Okay? So if I take a positive number, since I'm going to positive infinity, and plug it into the top, that's definitely going to give me a positive number. Now, it doesn't matter that I have this minus 3x over here, because that is so small in comparison to this, that for really large values, this top's going to be positive if the leading term is positive. Does that make sense logically? So if I substitute a number in to the top leading term, I get a positive. If I substitute a positive number into the bottom leading term, I get a negative, right? Because it's negative 3 times something squared, which is negative 3 times a positive, which is negative. So on the bottom, it ends up being negative, even though there's this positive x here, okay? Because the negative 3x squared is dominant in this case. If you substitute in really large numbers, this will always be bigger than that, okay? So since I got a positive in the leading term on top and a negative in the leading term on the bottom, the net sign here is negative, so this is going to be negative infinity. If I were to graph this function, to the far right of this function, it's going to go down to negative infinity. It's going to head down. Okay? If I took the same function and I wanted to find the limit as x goes to negative infinity, Same function, 5x cubed plus 2x squared minus 3x plus 1 over x minus 3x squared. I'll do the same analysis. I'm going to take the leading term on top. I'm going to take the leading term on the bottom. But this time, I'm going to substitute in a negative number because I'm going to negative infinity. On the top, I have 5 times a negative number cubed. Is that positive or negative? Definitely negative, right? When you cube a negative, you get a negative. So 5 times a negative is a negative. On the bottom, if I take negative 3 times the negative number squared, is that overall positive or negative? Also negative, right? Because when you square something, it's positive, but then multiply it by negative 3 gives you a negative. So this net sign is positive, so this is going to be positive infinity. So I don't really know a lot about this function, but I know that to the far left, it goes up, and to the far right, it goes down. Who knows what it does in between? So maybe it looks like this. It does some weird stuff, and then it goes down at the end. All right? That's what this function looks like. As you go to negative infinity, it's positive infinity. As you go to positive infinity, the limit is negative infinity. Okay, what it does in between, who knows? There's probably some asymptotes or whatever. Okay? So that's the bottom line. Pick a number that's either positive or negative, depending on whether you're going to positive infinity or negative infinity, and plug it into the leading terms to determine the sign. And that's going to give you the sign of the limit. It's either going to be positive infinity or negative infinity. Let's do one more example of this, and then I got a couple other things that are related to this that I wanted to talk about. What if I have the limit as x goes to negative infinity? This time, let's have it be negative 3x to the 5th plus 4x cubed minus 1 over, bottom is 2 minus x. So just looking at powers of x, I know this answer is going to be either positive infinity or negative infinity because the top is a higher power, right? So I'm going to look at the leading terms now. The leading term on top is negative 3x to the 5th. The leading term on the bottom is negative x. So if I substitute a negative number, because I'm going to negative infinity, if I substitute a negative number into the top leading term, is it going to be positive or negative? Positive, right? Because it's a negative 3 times a negative number. The 5th power, a negative number, it's negative. This is positive. If I take a negative number and substitute it into the bottom leading term, is it positive or negative? Also positive, because x itself is negative, but then I'm making it negative, which makes it positive. So overall, this is going to be positive infinity. Does that make sense? So that's how you can tell if the limit is going to be positive infinity or negative infinity. Now, technically, you could say it does not exist in both those situations, but for tonight's homework, they want you to actually choose one. Okay, so that's how you can choose one. Okay? The next thing I wanted to talk about is I was just going through some problems on Delta Math, you know, just for fun, and because that's what I do. And I encountered a situation that's a little inconsistent with something I said yesterday. So let me just talk about that for a second. And the problem that I came across looked like this. It was the limit as x goes to infinity, positive infinity, of the square root of 4x to the 6th minus 25x over 4x cubed plus 5x squared. So what we talked about yesterday is you look at the order of the top and the order of the bottom. So what's the order of the top here? It's 3, right? Because you're square rooting x to the 6th. So you're going to look at the leading coefficients because the order of the bottom is also 3, right? We have a 3 on top and a 3 on the bottom, so you look at the leading coefficients. So the leading coefficient on top is square root of 4. Remember that square root goes with it.
Right.
And the leading coefficient on the bottom is 4. So this ends up being 2/4 or 1/2. Right? That's what we talked about yesterday. Absolutely, that's correct. Okay? But what if we were taking the limit as x goes to negative infinity of the same function? I said yesterday it didn't matter. I was wrong. And it does matter because, think about this. It's the same thing I kind of just talked about. If you take a really large negative number and you plug it into the bottom here, it's definitely going to be negative, right? If you take a large negative number and plug it into this term, it's negative. The top's always positive, right? So how can the top be always positive and the bottom is going to be negative for really large negative numbers, but yet the limit is positive 1/2? That doesn't make any sense, right?
Wait, what do you mean it's always positive?
Because it's a square root. Square roots are always positive.
Oh, that's what you mean.
Yeah, square roots are always positive, right? So this is where it's a little bit inconsistent with what I said, because this limit's actually going to be negative 1/2. It's going to be negative 1/2 because the bottom for large values of x is negative. So since the top is positive and the bottom is negative for large negative values of x, this limit must be negative as you go to negative infinity. The other concept is still true. It's still going to be the fraction of leading coefficients, but you have to understand it's going to be negative in this case. Now, the reason why it doesn't matter normally if this was not a square root is because the powers of x would just cancel each other, even if they're odd. Like if this was x cubed and there's no square root here, but this was like 2x cubed, then the x cubed and the x cubed would cancel. So plugging in a negative number would make no difference, right? It's going to be a negative on top, but it's also going to be a negative on the bottom, so they'll cancel each other out. But with the square root, it changes things a little bit so that sometimes, like for negative numbers, this happens to be negative. Now, it's not always going to be different, but sometimes it will be different, and this is one of those cases where it will be. Does that make sense? But it's kind of the same concept that I just talked about. Did anybody come across any of these on last night's homework? Okay. So you might come across these on last night's homework. I'm not quite sure. I think that's where I got this problem from, is the last night's homework. So just be aware that that situation might come across. Okay. So then the next thing I want to talk about is, what if you have a rational function where you have other types of functions in there, like exponentials or logarithms or something weird, right? So it's kind of the same concept still. I just want to talk about relative rates of growth. Okay, relative rates of growth. So the order of things is exponential growth is like the fastest. This is the fastest. So that's greater than polynomial growth. And it doesn't matter what the exponent is on the polynomial. Exponential is always faster. So if you have e to the x, eventually, for large values of x, e to the x is going to be larger than x to the 1,000th power. Okay? Probably x to the 1,000th power will start out on top, but the e to the x will catch up to it and eventually pass it forever. Like it'll be ahead forever. Okay? So this is like the middle level of growth. And that's always greater than logarithmic growth. And it doesn't matter what the base of the logarithm is. That's like the slowest level of growth. And it kind of makes sense, like just graphically. If you picture what these graphs look like, exponential functions look like this. They start increasing really fast. It just like shoots up. Okay, polynomials, they also kind of do that, but at a slower rate. So like picture like a parabola or something like that. Yeah, it goes up to infinity, but at a slower rate. And logarithms, they also go up to infinity, but they actually are kind of like concave down. So they're definitely clearly slower growth than either of those. Okay? Why this is important is because sometimes you'll have a function that involves exponentials and polynomials, or logarithms and exponentials, or polynomials and logarithms, or something like that. And you can just compare rates of growth to determine the limits. Like, for example, if I had the limit as x goes to positive infinity of 5x to the fourth minus 8x squared over e to the x. Which is growing faster, the top or the bottom? Yeah, the bottom's definitely growing faster, right? Exponential growth is faster than polynomial growth. This is a polynomial. This is an exponential. This one's growing faster than this one. What happens to a fraction as x goes to infinity if the bottom's getting bigger faster than the top? What's the answer? 0, right? The bottom's blowing up faster than the top. That means this fraction is going towards 0. This equals 0. Since bottom grows faster than the top. So it's the same principle that we talked about yesterday, except instead of comparing exponents to see which one grows the fastest, we just compare the type of function to see which one grows the fastest. Okay? If they had something like the limit as x goes to negative infinity of, this is a little tricky. So let's say it was like something like log base 3, and I actually have to say of negative x, because you can't take the log of something that's negative. So if you go to negative infinity, you actually have to make this negative x to make it make sense. Over 2x. This is also 0, because the top's logarithmic growth, and the bottom is polynomial growth. Okay? So this is still going to be 0. The bottom is getting bigger, in this case a bigger negative number, but it's getting bigger at a faster rate than the top is. Okay? How about this? What if I have something like, or sometimes they might even try and hide something. Like, for example, they might write this function. They might write this as 5x to the fourth minus 8x squared times e to the negative x. But that's the same thing as that, right? So don't be fooled by that. Just write it as a fraction. Let's do one that's not written as a fraction. What about something like the limit as x goes to negative infinity of negative e to the 1 over x? What if that's the whole function? Any ideas about what this might be? Don't worry, I won't yell at you if you're wrong. So you say the answer is 0? I don't think the answer is 0.
Would it be approaching either positive or negative infinity, since you could make it a fraction like over 1?
Fraction over 1. It's not, no, that's not how fractional exponents work.
Yeah,
That's how negative exponents work. Fractional exponents are what Tommy said, they're roots.
Or like you could make the whole thing as a fraction over 1, and then
How
compare
how would you write that?
like negative e to the 1 over x all over 1, and then compare like that. I don't know.
Negative e to the 1 over x. Oh, I got you, like that. Oh, okay. That's true. Yeah, you can always do that. But so you're saying the answer is what? Positive or negative infinity?
I don't know.
Oh yeah. Okay. Yeah. I get your train of thought, but I'm not sure if that is the right path to take. What if we just look at the exponent? Forget about this for a second. If x is going to negative infinity, what is 1 over x doing? Yeah, this is like getting closer and closer to 0. So the overall thing is getting closer and closer to negative e to the 0 power. Yeah, so negative 1, right? So if the whole expression is getting closer to negative e to the 0 power, well, that's equal to negative 1. Anything to the 0 power is 1. So negative e to the 0 power would be negative 1. That's the limit. It's negative 1. Does everybody see the logic there?
Yes.
You're just looking at the exponent. The exponent itself is going to 0. Therefore, the whole thing is going to negative e to the 0. Okay, let's try another one like that. How about this one? What if we have the limit as x goes to positive infinity of 1 minus 2 e to the 1 over x power? So let's use the same reasoning. What is this exponent headed towards? 0 again, right? It doesn't matter that we're going to positive infinity. If the denominator gets bigger and bigger, whether it's negative or positive, it's going towards 0. So this whole thing then is getting closer and closer to 1 minus 2e to the 0, which is just 1 minus 2. The answer is negative 1 here as well. Okay?
Do the negative and positive infinity matter?
They don't. What's the difference? If you have 1 over x and you're going towards positive infinity, what would those numbers look like? It would be like 1/10, 1/100, 1/1000, 1/1,000,000, 1 billion, right? If you're plugging in bigger and bigger negative numbers, what's happening? You're getting negative 1/10, negative 1/100, negative. So the difference is you're approaching 0 either from the right side or from the left side, but either way, you're approaching 0. Okay? How about this one? What if I have the limit as x goes to negative infinity of 2x cubed plus e to the x over 6x squared minus 3x cubed? It's a trick question, so don't get too carried away.
Well,
What do you think?
Same, power,
Okay,
and you just pick a leading coefficient.
but what about the e to the x?
Oh, yeah, that's true.
That x value is
Negative.
so it's approaching.
Yeah.
Right, okay, good, yeah. So here's the thing. If you're approaching negative infinity, then e to the x doesn't get bigger and bigger and bigger. E to the x gets smaller and smaller and smaller. It gets closer to 0, right? Picture e to the x. E to the x looks like this. As you go to infinity, it goes to infinity. But as you go to negative infinity, it goes towards 0.
Right.
So this term is actually just headed towards 0, so you can kind of ignore it. And it is what you said. You're going to now look at the highest power of x on top and bottom. Since they're equal, then you're going to take the leading coefficient. The answer here is negative 2/3. That makes sense? So these problems, you kind of have to look at them on a case-by-case basis and figure out what's going on. Be careful about exponential functions. They look different if you're going positive or if you're going negative. It either blows up or it goes to 0. Okay? The last question you have to answer about these is sometimes they'll ask you, like, to identify the horizontal asymptotes. So all that means is take the limit as x goes to infinity. Take the limit as x goes to negative infinity. If they're the same number, then there's just one horizontal asymptote, and it's y equals whatever that number is. But sometimes the limits might be different if you're going to positive or negative infinity. In that case, there might be two horizontal asymptotes, one on the left and one on the right. They might be different. Or there might be none, like they might just go to infinity and go to negative infinity or something like that, in which case there's no horizontal asymptotes. So let me just summarize that for a second. So to determine horizontal asymptotes, just take the limit as x goes to positive infinity of f of x and the limit as x goes to negative infinity of f of x. If either of these numbers is a real number and not infinite, then whatever those limits end up being are going to be horizontal asymptotes. How could I say that in a nice way? If one or both of these limits are non-infinite, right? So either 0 or a number, then the horizontal asymptotes, and I'll put the S like in parentheses because there might only be one or there might be two. The horizontal asymptotes will be y equals whatever the limit is. Okay, let me give you an example. Like if I have f of x equals the square root of 25x to the 6th minus x squared over 6 plus 4x cubed. And they said, determine the horizontal asymptotes. You would just take the limit as x goes to positive infinity of this function and the limit as x goes to negative infinity of this function. Right? So in both cases, I'm going to look at the order of x on top and the order of the polynomial on the bottom, and I get 3. But this is that situation I was telling you about where they end up being different, right? Like if I substitute in a positive number, the top is going to give me 5x cubed, and the bottom is going to be 4x cubed. So they'll cancel, and you end up with 5/4. This limit is 5/4, right? But like I talked about a few minutes ago, if I go to negative infinity, this denominator is going to be negative. So this is going to be negative 5/4. So if they asked you, what are the horizontal asymptotes, you would say y equals 5/4 and y equals negative 5/4. And this is one of those problems where you have to remember to write it as an equation. They'll ask for the equations of the horizontal asymptotes. It's y equals whatever. Okay? So in this case, there's 2 horizontal asymptotes. So if you think about how a function can have 2 horizontal asymptotes, it's easy. Like you got one here and you got another one here. The function would just have to be like something like that. Like from one direction, it approaches one of the asymptotes, and going the other way, it approaches the other asymptote. This is still a function, and it has 2 horizontal asymptotes. Okay? Does that kind of make sense? Okay, so the reason why the notes were so long, and is because I'm not going to be here tomorrow. So I had to give you like 2 days worth of notes.
Okay.
So that's what this was. This was 2 days worth of notes. So whatever the homework is tonight, you're gonna have the whole period tomorrow to work on it as well. So you can save it till then, or you can do it ahead of time and bring other work to do tomorrow, or whatever you think. But there's not gonna be additional work given to you by the substitute. And there's no recorded lesson or live lesson tomorrow. That's the deal. It's still due Monday, yeah. Okay, so there's, it actually is just one assignment, but it was 2 days worth of notes. I would have broken it up if I was going to be here tomorrow. It's just called horizontal asymptotes and limits, I think. Limits and horizontal asymptotes and delta math, okay? I'm taking a day off because I'm getting my second COVID shot.
Hey,
You would broke, I thought.
Bacchus is getting his sometime soon.